Hello, future geologists. Whether you're just starting your journey or already fascinated by the mysteries of the Earth, you're about to meet the true superstar of our planet's story. Today, let's talk about water, H2O, the molecule that makes up nearly 60% of your body and covers over 70% of our planet's surface. It's everywhere, in the air you breathe, the food you eat, and the very rocks beneath your feet. Two tiny hydrogen atoms, one slightly larger oxygen atom, simple but absolutely essential. This little V-shaped molecule is the reason our planet is so unique in the solar system. Water is a rock star molecule, shaping continents, carving canyons, and making life possible. It's the silent artist behind the Grand Canyon, the sculptor of glaciers, and the force that wears down mountains grain by grain. Every sip you take connects you to a cycle billions of years old. Your water could have once been in a dinosaur's pond, a glacier from the last ice age, or even deep inside a volcano. Water has been everywhere, and it's been everything. Water is a world traveler and a shapeshifter, solid, liquid, gas. It freezes into ice, flows as rivers, and floats as clouds. No other molecule on Earth changes form so easily, and each form plays a vital role in shaping our world. It's the engine that drives Earth's systems, from weather to geology. Water powers storms, erodes rocks, and even helps create new land. Without water, there would be no rain, no rivers, no fertile soil, no life as we know it. As geology students, you're about to discover how water breaks down mountains, sustains life, and needs our protection. You'll see how it shapes landscapes, supports ecosystems, and connects every living thing on Earth. We'll dive into where water comes from, how it moves, and the challenges of keeping it clean and available. You'll learn about the water cycle, aquifers, and the delicate balance that keeps our planet hydrated. This isn't just for exams, it's for understanding our planet. The more you know about water, the more you'll see its fingerprints everywhere, from the smallest pebble to the tallest mountain. So grab your water bottle. We're following a droplet's journey through rivers, lakes, groundwater, and glaciers. Imagine tracing a single drop as it travels for thousands of years, shaping and being shaped by the world. We'll see how humans are changing water's story, and how science helps us find solutions. Pollution, climate change, and overuse threaten this precious resource, but innovation and awareness can make a difference. Let's get started, because the world of water is waiting. The more you learn, the more you'll realize. Water isn't just a molecule, it's the pulse of our planet and the key to our future. The amount of water on Earth is basically constant. No matter how much we use or how many millions of years pass, the total amount of water on our planet stays the same. It's a mind-boggling thought. Every drop you see today has been here since the dawn of time. What we have is what we've always had. The water in your glass could have once flowed through ancient rivers, or even been part of a glacier that existed long before humans walked the Earth. That's thanks to the water cycle, or hydrologic cycle, Earth's ultimate recycling program. This incredible system keeps water moving, cleaning, and transforming, making life possible for everything on our planet. Powered by the sun, water moves from ground to sky and back again. The sun's energy is the engine that drives this endless journey, lifting water from oceans, lakes, and rivers into the air. It starts with evaporation. Water heated by the sun rises as vapor. Invisible to our eyes, this vapor drifts upward, carrying with it the story of where it's been. Plants join in through transpiration, releasing water vapor from their leaves. This process is called evapotranspiration, and it's a vital part of the cycle, helping to regulate temperature and humidity in our environment. Water vapor floats up, cools, and condenses into tiny droplets, forming clouds. These clouds are like floating reservoirs, gathering more and more moisture as they travel across the sky. When droplets get heavy, gravity brings them down as precipitation, rain, snow, sleet, or hail. This is how water returns to the surface, sometimes gently, sometimes in dramatic storms. This delivers fresh water to land, filling lakes, rivers, and soaking into the ground. It nourishes plants, replenishes aquifers, and provides the water we all depend on. The journey continues. Water might flow to the ocean or seep underground, but its adventure never ends. Some water travels great distances, while some remains hidden below our feet for centuries. Every drop is part of a cycle billions of years old. The same water has shaped landscapes, carved canyons, and sustained life since Earth began. The water cycle connects every living thing on Earth. From the tiniest insect to the largest whale, all life depends on this ancient, ongoing process. And it all starts again with the sun. Each new day, the cycle continues, an endless adventure that links us all, drop by drop. When precipitation hits the ground, some become surface water, rivers, lakes, and wetlands. These are our planet's lifelines, supporting ecosystems and human civilization. Rivers shape landscapes, carving valleys and canyons through erosion. Just look at the Grand Canyon. They also deposit fertile sediment downstream, creating rich floodplains and deltas. Lakes, formed by glaciers, volcanoes, or landslides, store fresh water. Humans build reservoirs to store water for drinking, farming, and hydropower. But surface water is vulnerable. Pollution from farms and factories can contaminate it, and water levels change with the seasons. Floods and droughts are natural parts of these systems. Understanding these dynamics helps us manage water sustainably. Surface water is precious and it needs our protection. Not all rain stays on the surface. Much seeps underground as groundwater. Groundwater moves through porous rock layers called aquifers, nature's hidden sponges. It's often cleaner than surface water, filtered by soil and rock. We access it by drilling wells, providing drinking water and irrigation, especially in dry regions. But groundwater isn't limitless. It can take centuries to recharge. Overpumping leads to falling water tables, dry wells, saltwater intrusion, and even sinking ground subsidence. In many places, groundwater is the only reliable water source. Managing it wisely is crucial for cities, farms, and future generations. Aquifers are a hidden treasure, but they're not infinite. Careful use keeps this resource available. Even what's underground needs protection. Now let's head to the coldest places on Earth, glaciers and ice caps. Here, water is locked away as solid ice, forming some of the most breathtaking and remote landscapes on the planet. These frozen expanses stretch across continents, from the towering ice sheets of Antarctica and Greenland to the smaller mountain glaciers found on nearly every continent. These frozen giants are more than just beautiful. They store about 69% of Earth's fresh water, making them the largest reservoirs of fresh water on the planet. Without them, our global water cycle would look very different. Glaciers may seem motionless, but they're constantly on the move, inching forward and reshaping the land beneath them. Over thousands of years, they carve deep valleys, sculpt rugged mountains, and leave behind dramatic landscapes that tell the story of their journey. Glaciers are also like time capsules, trapping ancient air bubbles and particles within their layers. By drilling deep into the ice and extracting ice cores, scientists can unlock secrets about Earth's past climates, atmospheric conditions, and greenhouse gas levels from thousands of years ago. But these icy giants are under threat. As global temperatures rise, glaciers are melting at unprecedented rates. This not only raises sea levels but also threatens the water supplies for millions of people who depend on seasonal meltwater for drinking, farming, and hydropower. The evidence is clear: glaciers and ice caps are shrinking faster than ever before. Satellite images and on-the-ground measurements show dramatic losses in ice mass year after year. The loss of glaciers means rising seas, which threaten coastal communities, and less water for people living downstream. Rivers that once flowed strong with glacial melt are now running dry, impacting agriculture and daily life. Glacial landscapes are living records, etched with the marks of past ice ages and climate shifts. Moraines, striations, and U-shaped valleys all tell the story of how glaciers have shaped our world. By studying glaciers, scientists gain vital insights into how our climate is changing today, and what the future might hold if warming continues. The fate of glaciers is closely tied to the fate of our planet. Their survival depends on the choices we make about energy conservation and climate action. Protecting glaciers isn't just about saving ice, it's about safeguarding our water, our coastlines, and our future. Communities, scientists, and activists are working together to raise awareness and push for solutions. Ice is more than just frozen water. It's a living record of our world's history, a vital resource, and a warning sign for the future. The story of glaciers is the story of our changing planet. Where does all this water go? We use it for agriculture, industry, and at home. Agriculture is the biggest user. About 70% of fresh water goes to irrigation. This feeds the world but strains rivers and aquifers, especially in dry regions. Industry uses about 20% for cooling, manufacturing, and cleaning. Everything from your phone to your clothes needed water to be made. Domestic use, drinking, cooking, washing, makes up about 10%, but it's vital for health. Billions still struggle for clean water every day. Balancing these demands is a global challenge. Wise water use keeps societies running and ecosystems healthy. Every drop counts. As we use water, we often pollute it, turning clean rivers into toxic streams. Pollution comes from point sources like factory pipes and non-point sources like farm runoff. Point source pollution is easier to control. Factories can treat wastewater. Non-point source pollution is harder. Rain washes fertilizers, pesticides, and trash into waterways. Pollution causes algal blooms, dead zones, toxic buildup, and spreads disease. It harms wildlife and threatens human health. Understanding how pollutants move helps us prevent and clean up contamination. Protecting water quality is everyone's responsibility. Clean water is life. Let's keep it that way. Overusing water is like draining your bank account. Eventually, it runs dry. Pumping groundwater and diverting rivers faster than they recharge leads to shrinking lakes, dry wells, and even sinking land. The Aral Sea disaster shows what happens when we take too much. Climate change is making things worse. More intense floods, longer droughts, and melting glaciers. A warmer world means more extreme water cycles. Too much in some places, too little in others. Melting snowpacks and glaciers threaten water supplies for billions. Our water system is being reshaped by climate change. Science is key to adapting and protecting our future. We've journeyed from oceans to clouds, rivers to aquifers and glaciers to your tap. Water shapes our world, grows our food, and powers our lives. But pollution, overuse, and climate change threaten this vital resource. The challenges are huge, but so is our ability to solve them. As geology students, you're learning to map, model, and manage water for a sustainable future. Solutions need technology, policy, and a new way of thinking about water. Be curious, ask questions, and think critically about your water use. Become a water warrior. Advocate for wise, sustainable water management. The future of our blue planet depends on you. Go make a difference. Science rules.